Today we're going to talk about Cramer's rule, which is a way to solve a system of equations using matrices. So if we were given the system of equations we would have three matrices produced from a two set of equation systems of equations. So you would have matrix D, which is all of your coefficients. So that's going to be A, B, C, D. And so you have A and C from the coefficients of your x variables, and then you have B and D from the coefficients of your y variables. And then you're going to have matrix D sub x, which is where you're going to actually take your constants here, and you're going to replace the x column with those constants. And then your y column will stay the same. And then your third matrix is going to be D sub y. And so this is where your x column will stay the same. And then your y column will be replaced with the constants. To solve for x, you would do the determinant of d sub x over the determinant of d. And to solve for y, you're going to do the determinant of d sub y over the determinant of d. Now for an example, if we were given the system of equations 2x plus 6y equals -1 and x plus 8y equals 2, we want to make a note that in front of the x is actually an unwritten 1. And now we need to find our three matrices. So matrix D, if you remember, is going to be all of our coefficients. So we're going to have our x in the first column and our y coefficients in the second column. And then we need to have matrix D sub x, and that's where we're going to take our constants here and replace the x column with them. And then our y column will stay the same. And then we'll have D sub y, where our x column stays the same, but our y column is going to be replaced with our constants. Now we want to find the determinant of each of these 2 by 2 matrices. So if we want to find the determinant of matrix D, remember the determinant of a 2 by 2, you take A times D minus B times C. So we're going to do 2 times 8 minus 6 times 1, which gives us 16 minus 6, which gives us 10. And then the determinant of D sub x is going to be 8 times -1 minus 6 times 2. So that's going to give us -8 minus 12, which is -20. And then the determinant of D sub y is going to be 2 times 2 minus 1 times -1. So that's 4 minus -1. And when you have a double negative here, it becomes a positive. And so it's 4 plus 1, which gives us 5. Now we solve for x and y. So x is equal to the determinant of d sub x over the determinant of d, which would be -20 over 10, which would be -2. And then y is the determinant of d sub y over the determinant of d. So that's going to be 5 over 10, which is 1/2. And so our final answer we can write as a coordinate pair, -2, 1/2. Our next example is going to be a 3 by 3. So it's going to have 3 equations, which will give us 3 by 3 matrices. And so if we are given the system 2x minus 3y plus 4z equals 1, x plus 6z equals 0, and 3x minus 2y equals 5. And I left spaces so that all of my x variables, y variables, and z's were lined up. And so I'm going to fill those in here now. So it's going to be a plus 0y plus 0z. And remember, there's an unwritten 1 in front of the x. And so now we're going to create our matrices. So before we had a 2 by 2, so we only had 3 matrices there because we had d sub x, and d sub y. Now we're going to have 3 by 3, so we're going to have both 4 matrices, d sub x, d sub y, and d sub z. So we're going to start with d, and that's, remember, all of our coefficients. And so we're going to take them and do 2, 1, 3, negative 3, 0, negative 2, 4, 6, 0. And so we have here our x variables, our x coefficients, our y coefficients, and our z coefficients. So now we're going to do d sub x, and we're going to replace our x coefficients with our constants over here. So that's going to be 1, 0, 5 down that, and then the next 2 columns will remain the same. And then we're going to do d sub y, and that's where our y column will be replaced with our constants, and everything else remains the same. And then we'll have d sub z, and this is where our z column will be replaced with the constants, and everything else remains the same. Now we want to find the determinant of each of these, and so you can refer to finding the determinant of a 3 by 3 matrix by hand, or you could calculate the determinant of each of these in the calculator. So either way that you do this, you should get the determinant of matrix D is equal to negative 38. The determinant of D sub x is equal to negative 78. The determinant of d sub y is equal to negative 22, and the determinant of d sub z is equal to 13. Now we need to find x, y, and z. So x is going to be the determinant of d sub x over the determinant of d, which is going to be negative 78 over negative 38. And we can divide each of the numerator and denominator by 2, which gives us positive 39 over 19. We can find y by doing the determinant of d sub y over the determinant of d. Oops, typo, sorry. And when we do that, we're going to get negative 22 over negative 38. And again, we can divide each of those by 2, which gives us positive 11 over 19. And then we can find z by doing the determinant of d sub z over the determinant of d. And that's going to be 13 over negative 38. And that cannot be simplified. So then we can write our final answer as a coordinate point. And so we would have x first, then y, and then z. Last, we have the augmented matrix. And so if we're taking the given system from above, which was 2x minus 3y plus 4z equals 1, x plus 6z equals 0, and 3x minus 2y equals 5. And then I'm going to fill in all of our holes here. And so the augmented matrix is made up of your coefficients of x, y, and z, and then your constant. And so your augmented matrix here is going to look like this. And so I'm going to put a little dashed line right here just to show the break from the coefficients to the constants. And so we have our x coefficients right there, our y coefficients right here, our z coefficients right here, and our constants right there.